In this video, we will look at the earth-moving process. This is part of an earthworks. This is the main part of an earthworks project. This diagram shows the processes undertaken in a typical cut-to-fill process. For a cut-to-fill process, the soil is cut from the fill area and then transported or hauled to the fill area. At the fill area, the soil is spread in layers of about 200 millimeters thick, 200 to 300 millimeters thick, to allow it to be properly compacted. Any thicker would result in the bottom part of the layer not being properly compacted. As we discussed earlier, the fill material needs to be at or near the optimum water content to enable it to be compacted to its maximum dry density, which is where it will have its maximum bearing capacity. Therefore, we need to test the water content of the fill. If it is too wet, then we need to spread it out and allow it to dry in the wind and the sun. If it is too dry, then we need to spray water over it from a water cart. This wetting or drying can be done in the cut area or in the fill area. Once the soil is at the required water content, then it can be compacted using rollers, otherwise known as compactors, and then shaped using a grader. Each layer is tested to check that it has been compacted to the required density before the next layer is laid. If it has, then the next layer is placed and the compaction and shaping process repeats until the formation level is reached. Sometimes the compaction and shaping processes are carried out in conjunction with subgrade stabilization processes. Stabilization process involves mixing lime or cement into the top 200 to 300 millimeters of the subgrade surface and adding water. Adding water to the lime or the cement initiates a chemical reaction much like that which occurs when concrete is mixed. The result is a hard material that has a higher bearing capacity than the original soil. Stabilization is usually undertaken when the soil is too soft or the road loads are too high. However, it can also be used to dry the soil and improve other soil properties. The compaction and shaping operations need to be carried out in conjunction with stabilization processes, and the final formation surface, the final subgrade, needs to be completed in the same operation. This is because the stabilized material sets to a very hard material which is very hard to compact and shape within the day. If there is more material, cut material than fill material, that is, there is excess soil, then some of the soil needs to be disposed of. Alternatively, some of the cut material may be too soft or have other properties that makes it unsuitable for use as fill. This unsuitable material needs to be disposed of. Excavating and disposing of excess or unsuitable cut material is called cut to waste. The waste material is usually hauled off-site for disposal at a clean fill or a fill area on another site. Sometimes you might find a fill area on the site that you're working. Note that this operation usually requires the trucks carrying the waste soil to use public roads, so on-highway trucks need to be used, rather than moxies and other specialist earth-moving equipment that is too heavy for public roads. Sometimes we do not have enough cut material for all of the fill. This is usually because there is less soil produced from the cuttings. However, it may be that the cut material is not suitable for use as fill. It may be too soft or have other unacceptable properties such as swelling excessively when wet. In these cases, some or all of the fill will need to be imported from off-site. The fill may be sourced from other projects that have excess cut material, or may come from quarries which usually have material that is unsuitable for use as aggregate but does make good fill. Importing fill is very expensive, as you often have to pay the transport to transport the fill for long distances, and sometimes the fill material itself has to be purchased. Often it is better to do additional cutting or open up a borrow pit on site to get the fill. A borrow pit is an excavation undertaken to obtain fill outside of the designated cut areas. So the fill only operation starts with hauling the fill on site rather than cutting. The following processes are the same as for the cut-to-fill operation. We will look at these earth-moving processes in a bit more detail in the following videos.